right, arithmetic and geometric sequences. We're going to do this today. We're going to practice tomorrow. I'm squeezing these 2 days of notes into one because they're short, sweet, and simple, okay? All right, sequences are just lists of numbers, okay? So there's a fancy sequence called the Fibonacci sequence. In order to get the next term, you add the two previous in front of it, okay? So 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8, and so forth, okay? Now, we are specifically going to look at the types of sequences that we have a pattern to help us find what comes next, okay? We have infinite sequences. That's the ones where we have the ... at the end. Just tells me that it keeps going. And then a finite sequence. Finite just means finish, okay? The nth term is just the term that you're looking for. And then the term of a sequence is the actual number itself, okay? So here we go. Write the let me go back up right here. A sequence has an explicit formula of a sub n equals 12n plus 3. Now, the explicit formula is the direct, I'm going to plug in the number of the term that I'm trying to find, and I'm going to get my output. So if I'm asked to find the 12th term, a sub 12, you have the sequence 12 times n plus 3. If 12 is my number right there, okay, I'm going to go plug in the 12, and then I'm going to work it out. 12 times 12, 144, plus 3, 147, and that's it. Okay? If I'm asked to find the first four terms, I've got A1, A2, A3, and A4. I'm simply going to plug in 1, 2, 3, and 4, work it out, and get my sequence. So I like to go ahead and just set this up. Anywhere there is an N, I put parentheses. And I'm going to plug in 1, 2, 3, and 4. And I'm not going to use a calculator for this because these are easy numbers. 3 times 1 is 3. 3 minus 4 is -1. 3 times 2 is 6, and 6 minus 4 is 2. 3 times 3 is 9. 9 minus 4 is 5. 3 times 4 is 12. 12 minus 4 is 8. Okay? Now, you could keep that going, but what I would like to show you is if I were given a list of numbers and this was the sequence, it might look something like that in an actual list, okay? And what I want you to see, and the connection I want you to make, is that here I am adding 3 every single time to get the next term. Where do you see a 3 in the formula? Connected to the N, right? Okay, that 3 is what I call my common difference. All right, same thing right here. I want to find the first 4 terms. A1, A2, A3, and A4. Just going to write down my formula. Plugging in the number of the term that I want to find. Should have been 1. Okay, what is negative 1 to the first power? Negative 1. 5 minus 1 is 4. What's negative 1 squared? Positive 1. And 5 plus 1 is 6. Negative 1 to the third power? Negative 1. Remember, that's not negative 1 times 3. Okay, it's negative 1, negative 1, negative 1. So 5 minus 1, again, is 4. And then anytime I raise a negative number to an even power, it's going to be positive, so that's a positive 1. And I get 6. Okay? This right here is not an arithmetic sequence. Why would I say that? You're not adding the same thing over and over again. Yes, it is like a pattern. We see that there's some repeat happening, but I'm not adding the same thing every time, okay? So that is not an arithmetic sequence. There is no common difference. Okay? All right, find the first 3 terms of this sequence. So A1, A2, and A3. Now, these are very much like a linear function, okay? Arithmetic functions or arithmetic sequences are connected to linear functions. So 4 plus 1 minus 1 times 5. 4 plus 2 minus 1 times 5. And 4 plus 3 minus 1 times 5. What's 1 minus 1? 0. So this whole back part just goes away because 0 times 5 is 0. And then you've got that 4. 2 minus 1 is 1. 1 times 5 is 5. 4 plus 5 is 9. 3 minus 1 is 2. 2 times 5 is 10. 10 plus 4 is 14. Okay? This number right here, this 5, that's what we're adding by every time. So this number is my common difference. All right, then this one asks me to find the 11th term. The good thing about the explicit formula is you don't have to know all 10 that come before it. You can directly plug in 11 to get the 11th term. Okay, 11 minus 1 is 10. 10 times 5 is 50. And 50 plus 4 is 54. Okay? Short, sweet, simple. Okay? All right. Now, I don't like these ugly formulas that are right here. Okay? So I'm going to go back to what we did in Algebra 1. Okay? And I'm going to give you these formulas on any quizzes or tests. Okay? All right, my explicit formula, the direct formula, and that's the one that we were just using. We need our first term, our A1, and then we have plus n minus 1 times your common difference. A1, which is your first term, D is common difference. Okay? Now, our recursive formula okay, explicit or general form, that means the same thing. A recursive formula is the other formula we used in Algebra 1. What that does is it takes the term right before the one I want to find. So this right here is your previous term. And you are going to add the common difference to it. Okay, explicit or general form just means find the direct formula that gets me what term I want, and the recursive formula uses the previous term. Okay? Forget all this other mess over here. All right, analyzing arithmetic sequences. I want to know, is this an arithmetic sequence or not? If so, I want to write the general rule, which is the same thing as the explicit formula. Explicit. Not explicit as in lyrics or language, even though I know sometimes you'll probably feel like using explicit language when it comes to pre-calculus. Hopefully you're feeling like you're surviving. Told you I would take care of you. Okay? All right. Right here, that is my first term. My 1 is my A1 because it's the first term in the list. And I need to see, am I adding the same thing over and over and over again? Yes. What is my common difference here? Positive 4. Okay? So I'm going to substitute into this formula. I only need 2 things. I need my A1 and my common difference. Okay? So my A1 here was 1. We'll leave the n minus 1 just like it is. And my common difference is 4. I'm going to put parentheses around that because that right there is still being multiplied. So we have to simplify. So that means we have to distribute and combine like terms. So this is 1 plus 4n minus 4. My like terms are these two. So my formula is 4n minus 3. Okay? Here I'm asked to find the 46th term of this sequence. Okay? I need 2 things. I need my A1 value and I need my common difference. What am I adding over and over here? 3. Okay? So my 46th term, we are going to do my A1 plus 46 minus 1. Your n is 46. And you're going to multiply that by your common difference. Okay? So I have 2 plus 45 times 3. 45 times 3 is 135. Okay? So my 46th term is 137. Is this so bad so far? Good. Okay. All right, then down here, I'm asked to find the 9th term of the arithmetic sequence whose first term is 8. So A1 equals 8. And has a common difference of negative 5. Okay? So I'm finding the 9th term. I've got 8 plus 9 minus 1 times negative 5. 9 minus 1 is 8. So this is negative 40. The ninth term is negative 32. Oop, that's not my phone. Okay. You got it? All right, let's flip it over. Okay, still finding general terms, okay? This asks me to write the general rule, okay? What do I see is happening in this first list? What am I adding over and over again? 0.25. I'm adding a quarter every time, okay? If y'all don't like fractions or decimals, just think of it in terms of money. Okay, now you get that. All right? Also need my first term. So, a sub n equals my first term plus n minus 1 times my common difference, which is 20.25. We have to distribute and combine like terms. So 0.25n minus 0.25. My like terms are my dollar and the negative 25 cents. So if I take away a quarter from a dollar, how much do I have left? 75 cents. Okay? All right, I want you to try B. Okay, you and your seat partners work together on B. Let's see if you get that. I'm going to pull mine to the side and I'm going to work that out as well. I wrote my answer down in two different ways, okay? Are you ready? Why do you think I put a purple star by the one on the top? Huh? Yeah, it can be written like that. This is actually my preference. Does anybody know why?
Variable comes first.
Yeah, your variable comes first. Y equals mx plus b. This right here is in that slope-intercept format, okay? I'm going to write that out to the side. Y equals mx plus b. All right, any questions so far? You're going to be given these formulas. I just need you to know how to use them, okay? All right. Let's look at this situational problem right here. Says the number of seats in the first 16 rows of an arena form an arithmetic sequence. If there are 20 seats in row 1, 23 seats in row 2, how many seats are going to be in row 16? All right, real quick. In row 1, there's 20 seats. In row 2, there's 23 seats. And then that pattern continues. Okay? What is it increasing by? 3. That's my common difference. And this right here is my A1 term. So if I'm trying to find the 16th row, I have a direct way of solving that. You take your A1 term, you do the n minus 1 times d. Well, n is 16. And my common difference is 3. 15 times 3. That's 45. So I'm going to say A16 is 65. Because this is a situational problem, okay, and like a real world problem, I'm going to write my answer. I'm going to say in the 16th row, there are 65 seats. Okay? I'm blind. Okay, flip it over and let's swap over and talk about geometric sequences, okay? Geometric sequences, we're not adding the same thing over and over again. We are multiplying the same thing over and over again. Now, with arithmetic, it can look like addition or subtraction, okay? Y'all please put your laptops away. I am not anywhere doing anything. We ain't watching film. I know. But we're not going to be doing anything else right now either. We're going to focus on this so that we have a rock star test grade at the end of this unit. This is the easy stuff, and I don't want you to miss the easy stuff, okay? All right. Arithmetic sequences. Your common difference can be positive or negative. That's your adding or subtracting, okay? If I don't see your eyeballs, you're sleeping. So y'all best wake up. Okay? Y'all don't think I still can't get to you. Y'all still got 6th and 7th period. Okay? All right. With geometric, it can look like I'm multiplying by the same thing over and over again or dividing by the same thing over and over again. But we don't write these as division. Okay? If it looks like I am dividing by 2 over and over again, that's the same thing as multiplying by 1/2, okay? So we're just going to write it as like a little reciprocal, okay? Right here, what am I doing over and over again? You're multiplying by 2, okay? We call these a common ratio. Okay? We have a common ratio with geometric sequences. Okay? Here is my explicit formula. You need 2 things. You need your first term, and you need your common ratio. The n minus 1 is just like in that arithmetic sequence. You just leave it alone unless you're plugging something into it. Okay? If I don't know the common ratio, if I've got a list of numbers, what does it mean to be consecutive? Back to back, okay? You can take any 2 back-to-back numbers and divide them. You got to do the one that comes second over the one that comes right before it. Okay? We're going to look at that in a minute. The third term divided by the second term. The fourth term divided by the third term. Anything divided by what comes right before it. Okay? We also have another general form. Okay? This one is where I am using what I would consider my y-intercept. Okay? If a graph crosses the y-axis, that would be considered your 0th term, not your first term. Okay? In real world problems, we might call this our initial value, which is the amount at time 0. Notice in this formula you don't have the n minus 1, okay? Don't worry about this. Okay, we're just going to use our old school Algebra 1 stuff. All right, for these examples, I'm going to use my explicit formula up here, okay? All right, it says determine whether each sequence is geometric, and if so, find the common ratio, okay? Am I multiplying by the same thing over and over again here? Yes, okay? What am I multiplying by every time? 2. So a check mark, and my common ratio is 2. 6 divided by 3 is 2. 12 divided by 6 is 2. 24 divided by 12 is 2. This is what I mean by any 2 consecutive terms divided should give you a common ratio. Okay? All right, what about B?
Yes.
Yes. You are multiplying by -3. Okay, what do I multiply by 1 to get 5? 5. So if I multiply 5 by 5, I should get 25, and that's not right, so I'm just going to put an X there. Okay? Do you notice how on D the numbers are getting smaller? Okay? Perfect. -1/4. You divide 48 by 4 to get 12. But because it changed signs, it has to be a negative. And then if I divide -12 by if I divide it by -4, that gave me a +3. Okay? Because it's getting smaller, so therefore you have to write it as multiplication. So this is just recognizing whether it's geometric or not. Okay? Flip it over. All right, find the indicated terms of the geometric sequences. I am asked to find A6 and A sub n. This right here is where I would start. Okay? This is just the explicit formula. So we're going to use this formula. I'm just rewriting it because it's on a previous page. We need 2 things. We need our first term. We're going to substitute that in there. And then my common ratio is what here? -5. Okay? So my first term is 3. I'm going to put -5 in parentheses and due to the n minus 1 power. That is my general rule. Okay? That took care of that first part. So I'm going to check it off. Now I'm asked to find the 6th term. So 3 times negative 5 to the 6 minus 1 power. If I simplify this, this is 3 times negative 5 to the 5th power. Okay, so I'm going to grab my calculator. I don't expect you to do this without one. Okay. I have 3 times negative 5 raised to the 5th power. Everybody type this in, please. And I should get for my 6th term negative 9,375. Okay? You okay with that? Plug it in.
So you plug it in before you did
Yeah, you could have done up here 6 minus 1. Still get the same thing. Okay? All right. Now this is what I need you to do on part B. I need you to put a big old star right here. And I'm going to go ahead and preface this that this is going to be the hardest part of this. Okay? There are a lot of steps that have to take place in order to determine my common ratio and my first term here. Okay? Now, I am going to be using this formula from that front page. What I am given right here is my 4th term and my 11th term. Those are not even back-to-back terms, right? So I can't find out my common ratio the way that this is given, okay? Here's what I know. I know that my 4th term, when I plug in 4, I get out negative 8. So negative 8 equals A1 times my ratio to the 4 minus 1 power. When I plug in 4, I get out negative 8. That's all I know, okay? I can simplify this, and I recommend that. So this is R cubed, okay? I'm going to leave this just like this for right now. Okay? I also know that when I plug in 11, I get out the fraction 1/16. So 1/16 is equal to A1 times the common ratio to the 11 minus 1 power. When I plugged in 11, I got out 1/16. Where did I put the in?
No, what did you put in? I can't.
11. All right, I know my highlighter's a little bit dark. Okay? All right, now, right here, I'm going to simplify. I've got 1/16 equals A1 here times R to the 10th. The only thing that is exactly the same in both of my equations right here is the A1. The R's are not the same because they have different exponents. So this is what I'm going to do. I am going to rearrange this equation, and I'm going to solve for A1, okay? How do I get rid of this multiplication by R cubed? You divide it, okay? All right, now, right here, underneath here. Okay, I'm going to say here that A1 is equal to negative 8 divided by R cubed. You don't want veggie straws? Okay. Now, because this is now equal to A1, I am going to go substitute this expression in to this function. Okay, all I'm doing is I'm going to take this negative 8 over R cubed, and I'm going to substitute it in for A1. Okay, so right here, 1/16 is equal to negative 8 over R cubed times R to the 10th. Okay, look. A1 is what I changed, right? I rearranged this first equation to be solved for A1. If A1 right here is equal to negative 8 over R cubed, and these A1s have to be the same in both equations, I can take this and drop it in this A1's place. Okay? Y'all need to sit up. This is going to be on quizzes, and it's going to be on tests, and I do not care how much you whine about it. Now, right here, R to the 10th can be written as a fraction. We multiply fractions straight across. So this is 1/16 equals negative 8 R to the 10th over R cubed. I can divide out 3 of those R's, so I'm left with R to the 7th. So I now have 1/16 equals negative 8 R to the 7th. The whole point here is to get rid of one of the variables so that I can solve for the other one. Do you notice how right here I had 2 variables, but then right here I'm only working with one variable. I'm only working with the R because I want to combine that, so now the only variable I have left is the R. I can work backwards and now solve this equation for R. Okay? This negative 8 is being multiplied. So I'm going to divide both sides of my equation by negative 8. Okay? I'm having to squeeze it in too, I know. Okay, so I don't want to do this without a calculator. Okay? We do alpha y equals and choose number 1. Do you see how I have a fraction in the numerator? Do alpha y equals number 1 one more time. And it puts a fraction in the numerator. So I've got 1 over 16. And then in the denominator I've got negative 8. hit enter. What'd you get? Negative what? She got negative 1 over 128 equals r to the 7th power. All right, now if this were r squared, how would I get rid of the square? Square root. If this were r cubed, what would I do? Cube root. So if this is r to the 7th, I'm going to do the 7th root. Okay? So I'm going to take the 7th root of both sides of this equation. Okay? On your calculator, there is a button right below alpha that says math. Hit the math button and look at number 5. Do you see how there's a little X right there? Okay? That X is where we're going to put our 7. Okay? Now, some of your calculators, if yours is like mine, okay, some of your calculators are going to pop up and give you the box to plug into. Others of you, if you have the not updated calculators, how many of your calculators say ANS and then have the square root? Can you bring me your calculator because I want to show everybody what I'm talking about? Okay? Now, this is the easy one because all I got to do is type in the 7 and there I go. Okay? But if you take a look at Nick's calculator, do you see how I have ANS? That is taking the previous answer that I got in my calculator and using that as the root. I definitely don't want that because that was like negative 9,375. Okay? All right, so what I want to do, I'm going to arrow backwards until it is highlighting that A. And I'm going to type 7. It changes it. Okay? Now, another way to do this, I cleared out what I have here. Okay? If I know that I'm taking a 7th root, I can type in the 7 before I hit the math button and choose number 5, and it automatically puts the 7 in there. It really just depends on what calculator you get, okay? So I just want you to know how to work with both. Here you go now. Thank you. Okay? All right, now, underneath the radical, we want to put a fraction. So we're going to do alpha y equals, and we're going to do negative 1 over 128, negative 1/2. So R, my common ratio, is negative 1/2.
Negative 1/2?
Negative 1/2. Okay? All right, now I have only solved for R. Davis come back in and missed the hardest part of this whole thing.
Pay attention, right?
It's not his fault. I know. The good thing is it's not going to take long to find my A1. Okay, now look right here. Okay, I know that in my 4th spot, my A4 was negative 8. Okay? And I know that moving forward, grab the door. Oh, y'all couldn't see what I was doing. Mercy. Okay, I put 4 blanks, and I put my negative 8 in that 4th position. Okay? Moving forward, we multiply by negative 1/2. Okay? So if I multiply negative 8 times negative 1/2, first of all, what's a negative times a negative? positive. And what's half of 8? 4. Okay? So my numbers are getting smaller the further I go. But I need to go backwards so I can find my first term. So rather than dividing by 2, I'm going to multiply by -2 because they have to alternate signs. Yep. So right here, this is going to be 16, -32, and positive 64. So here my A1 is positive 64. Whew. And so it is. Okay, this is the hardest part of all of it. Okay, yeah. All of it but this one. Tomorrow, yeah. Huh? Y'all will probably have a quiz on Tuesday and a test on Friday. Okay? All right. Now, this is recorded, so y'all don't have to stress. I'm putting it on YouTube and Canvas. Okay? Next calculator on YouTube. Okay, we're going to skip down to example number 12. Okay? All right. This is a real life thing, friends. Okay? You are offered a starting salary of $37,500 for the first year. That's not really a lot, friends. Okay? With an annual increase of 5% each year. First of all, if you have a percent increase, that is going to be a geometric sequence. Okay? If you have a percent increase or decrease, let me say that, increase or decrease, it will always be a geometric sequence. If your increase is a constant increase or a constant decrease, then it's arithmetic, okay? All right, now, if it is a 5% increase per year, that means your salary will be 1.05 times what it was in the first year. What would you expect to earn in your 5th year? All right, there's a couple things that I am able to pick out of this situation. My first term, which is how much? $37,500. And your common ratio is 1.05. Y'all just wait till I call on you to answer my question since y'all playing back there.
You should make them go to the board right now.
I should. Okay. All right. Now I am asked to find what my salary is going to be in the 5th year. Okay. So I am using this geometric sequence right here. Okay. So $37,500 times my 1.05 to the 5 minus 1 power, which turns into a 4. Now I'm going to do an approximation here because we know that if I get decimals behind what I need for money, I'm going to have to round. So 37,500 times 1.05 to the 4th power. How many decimal places do I need for money? 2. So I have 45,581 and 48 cents. Now, you better rest assured that company is not gonna round up and give you a 49 cent. They're gonna keep their money.
It's okay.
I got a question.
Yep,
How should you times the 37,100 multiply it by 1.05?
because then you'd be adding the same thing together 5 times in a row. And if I add $37,500 times 1 point, yeah,
I got the same answer, that's what I did.
Yeah.